G'day folks. Well, for tonight's little unboxing opening fun, we have my new TIG welder. It's only a cheap one, it's worth a try for $250. Getting the gas and everything set up is going to cost about $300, so I figure we'll go fairly cheap. It says inverter based technology, and it's certainly light enough to be a inverter welder, given that it's 200 amps supposedly. I've got a feeling the first thing I'll be doing is upgrading the fans and everything on it, because I know these modern inverters tend to die from heat, really. You start cooking the IGBTs in the inverter output stage and they just go pop. Sometimes violently, they blow themselves to pieces. I found a couple at the scrapyard that had already been opened, and the big IGBTs, or not so much big, but the little 203 packages or whatever they are, they were just completely blown to pieces. You couldn't even tell what number or part they were. They were just obliterated. Big burns on the main board. So yes, we have a pretty decent little unit, I hope. I doubt it would have HF start or anything like that. I would only expect that in a high-end TIG. It'll be a scratch start, but it only does DC, supposedly rated to 200 amps. I'll certainly be testing that theory, but yeah, it should be good. And apparently it comes with a regulator and everything, so that's good. I've got to get the gas account started tomorrow and pick up a gas bottle as soon as the account's active and ready to go. I'll probably also pick up a maybe a second bottle for just purging, blow gas through stainless steel tubing and things like that, so it doesn't oxidize on the inside. It's back purging, I guess you call it, particularly for the jet engine combustor. I want to back purge that whole thing and yeah, have no excess burnt stainless steel on the inside to flake off and go through the turbine. Mind you, the old housing on that turbo is pretty rough, and I've got a long-time subscriber of mine, or an avid subscriber of mine, offering to donate a couple, or at least one large turbo off an old Cummins engine, so that'll be a good start. I think he said it was a twin turbo diesel or V8 or something like that, but even just one of them would be perfect. I don't really have the resources or the need for a twin turbo jet, even though it'd be fun. Yeah, this welder should be the beginning of a whole new era for Ed Systems. We manufacture systems of things and have a lot of fun, and TIG welding's another big addition for this workshop. It's going to be fantastic. Okay, the welder itself's not too bad. Duty cycle wise, 40% duty cycles at 200 amps, 18 volts. So if you want 100% duty cycle, 126 amps, 15 volts, that'd be fairly conservative. I mean, if I'm welding 3mm or smaller stainless, you don't need it that high. So you can almost run this all day without a problem, as long as it stays cool. Some nice big heat sinks in there. I don't see any warranty stickers, so I don't see any reason not to take the top cover off and have a look. It does say to actually clean it out with compressed air regularly, so I guess they intend for you to remove the top cover and give it a good clean, because, well, conductive or semi-conductive workshop dust does have a habit of killing inverter-based welders. That's an Australian plug, that's a Clipsal plug, so they've obviously chopped off the Chinese plug and replaced it with a proper 13 amp Australian standard plug. And it comes with a small array of shields and collets and things like that. It's got a 1/32 and a 1/16 variety. There's only one tungsten electrode, but I'll buy a few packs of replacements. There's a collet holder, there's only one of those. So I'll see what's available at the moment. Or at least at my local bolt bar, which, as an emergency, they do charge an absolute arm and a leg for anything. But just as an emergency type thing, I'll take one of each in there and just see if they have it on the shelf. So if I do break something or mess it up, I can just go down the street and buy another one without having to order it in. But I've got a feeling I'll be ordering some more bits and pieces from BOC Gas and Gear and putting together a little carry box with pretty much everything in it. More shields, particularly bigger shields. They're a bit too small for my liking unless I'm running that tiny little 1/32 or whatever it is, 1.2mm tungsten electrode. That's getting closer to what I normally use on the Kempi at work. It's a number 5. I use a number 6 and a number 7 normally. I think 10 or 11 for alley, which is almost basically just a parallel shield about that big, and double the gas flow. So you wind it up till the ball's at the very top of the flow meter. That's one thing this doesn't have, is the regulator. I can't remember if it was actually advertised in the auction or not, or the purchase. It might have been another welder I was looking at, but either way I can grab one of those easy enough. I've still got to get the bottle and all that stuff. Ground lead or workpiece lead is not too bad. Reasonably thick, heavy cable. Slightly underrated for 200 amps. It's 16mm cable, so it's not too bad. Clamp's good. Clamp's acceptable. I've bought worse from replacement stores. Yeah, clear vinyl hose for the argon, or whatever shielding gas I'm going to use. I'll start out with straight argon because that's what I'm used to using, particularly on stainless. But I might even swap over to a blend or a tri-mix maybe. I was talking to Obliterus on the Geek Group IRC for a bit the other night, and came up with some good gas alternatives and things, so it's worth a look in. Got the torch assembly here. Pretty straightforward. I don't know if it would have HF start. I'd hope it would, being an inverter based welder. It's not just a basic transformer and rectifier assembly. It's a pretty decent one. It'd be nice if it had HF start. I'm not holding my breath on it, but it might. So yeah, worth a try. Anyway, I guess I better I can find a suitable box for some of these small parts so I don't lose them, and then we'll have a look at the welder itself. I'll also be ordering a I think they call it a cowboy shield or a cowboy liner that goes over the outside of this jacket, they call it. It's basically just a zip up leather jacket that goes all the way over the outside of this silicon rubber, well, protective jacket that's already on there. It's an extra protection thing, because these do eventually split and just fall apart. They don't last. So you're better off protecting it now while it's new and just forget about it. That and zip ties, tape, everything. The one on the Kempi's held together with everything you can find around the workshop. It really needs to be fully stripped off and replaced with a whole new jacket. It's actually got poly spiral binding for cable all around it. It's a 20mm spiral binding for cables. So that's all over the one at work, which is messy but works. Again, flex hose for shielding gas, not too bad. I'm going to put my own solenoid at the cylinder low pressure side, just so that it comes on when the weld is on and goes off when the weld is off, just in case I forget to turn something off. There's no gas control on the torch, so I'm guessing there is a solenoid in the machine, but I wouldn't trust it not to leak a tiny bit, and gas is very expensive, so I don't want to waste a bottle of gas just leaving it, forgetting to turn it off over a weekend or a whole week or something like that, and finding out I've got a empty cylinder. That's not fun. Okay, well, you get a lot of componentry for 250 bucks. That's the top control, that's fan. That's control from the front panel and the LEDs. That, I don't know what that is. It's only got 2 wires going to it. It's got an awful lot of SMDs and what looks like a so either a transformer or an inductor. No, it's a transformer. It's got too many wires, it's not just an inductor. So there's the inverter bridge. Those are all marked D, so that must be diodes, maybe fast switching diodes. And they're all marked Q, so they're transistors, or probably IGBTs. That looks like a big inductor. It's got a ferrite core through the centre of it. And 2 little wires coming off there. Oh, there's a little spark gap in there. I think this thing does have HF start. That's sort of like a Tesla coil. that injects a high frequency, high voltage charge into the, yeah, it is too, there's the HF start side, all those big high voltage caps and diodes. Shit, that's really good. That's what I want. No more scratch start cheapos. Yeah, that's really, really good. That transformer in there will be the high voltage supply, like several tens of thousands of volts at a few milliamps. Not a lot. I mean, I've been zapped by the Kempi at work, which has a transformer about that big on it, like it's the size of a flyback, and it really does wake you up when you zap yourself with it, but it's certainly not lethal. It hurts, but it's not lethal. So I'd say, since it jumps a gap about that big, I'd say it's more like 60 kV, kind of like a low-powered car ignition coil. And yeah, but yeah, that's a little spark gap in there, that little one in there. Yeah, that's HF start, that's HF injection into the main current output, which is, well, the big copper coil. Those thin wires will be wrapped finally around that ferrite core inside. I can't quite see it, but it's all potted in conformal coating resin. There's two big bridge rectifiers on the underside of that these heat sinks. The wires are all paired up, so I'd say that they're feeding almost like a two-phase type output stage, or sorry, inverter stage. Yeah, it splits the single phase input into two separate DC feeds for the DC inverter bus. Might pop one of those little clamps off the top and bottom and just see what kind of semiconductors they're using. Standard caps, 470 mic, 450 volt, there's 4 of those. Looks like 2 for each side. Giant MOV, that's the biggest MOV I've ever seen. Look at the size of that thing. It's badass. Is it an MOV? It says RV2 next to it. Yeah. RV2. It's got a little thermistor. That's a relay. There's another relay behind it. Optocoupler. A very wonky connector. I'll set you back down again. Little things like that. Some of these, yeah, it is Chinese. You get what you pay for. But yeah, that coil there is HF, high voltage, high frequency start injection into the main output, just like a Tesla coil. Certainly been around a long time, that kind of method of arc starting. What are you doing? Okay. Oh, they're plastic. These heat sinks are probably part of the circuit. Yeah. That's all plastic. And you're going down to, oh, there's a bracket to the chassis, so that's ground. And there's a tiny little MOV or something on there. I guess maybe it detects if the output stage goes short to the heatsink, it automatically, yeah, if it's on an RCD or something like that, it'll trip it out. It's just a little safety feature by the looks of it. Some nice big inductors there, 2 wire, 4 wires. Yeah, big inductors, toroidal inductors. Not bad. I'm not going to pull it down any further than it is, even though some of this stuff looks pretty wonky. I might check some of the main connections, if anything. Yeah, let's pop one of these little plates off the top and bottom. Let's see what these diodes are, and we'll see what these transistors or well, IGBTs are. Doesn't look like there's anything else inside. It's just a big pair of what look like Radio Shack off-the-shelf amplifier heatsinks. And these feed the bridge rectifiers up there. They look like 30 amp or 25 amp bridge rectifiers, 2 of them. Oh, and mains inputs here. Black and red are mains input to the thermistor and the giant MOV off the main switch. Yeah, pretty good. And I've got mail. Okay, well these diodes are just 20 amp, 200 volt, fast recovery diodes, pretty straightforward. We'll remove the top one, have a look at that. They did spring away from the heatsink, so I'll get a piece of very thin mylar and just slip a bit more thermal compound behind them. They don't have a lot of compound on them, and these are usually the ones that I see burned up or blown out on the dead welders that I've seen in the scrap bins. Usually it's pretty catastrophic failure. There's a lot of burning going on inside when they do go. You have to wonder if the things are properly protected or grounded even to begin with. Because should trip out before fire starts, but I've seen a couple that have caught fire. Okay, well I've seen these before. These are just Toshiba field effect transistors. They're not IGBTs like I thought, but they're still very good. They're a 500 volt, 15 amp FET. I'm pretty sure I've got a whole pack of new ones in stock somewhere. They're quite handy. It's actually good to have them in stock when you're working on this sort of thing. I'm pretty sure I've seen them in a lot of plasma TV power supplies too, particularly the older ones. That's probably why I've got a pack of them in stock. They seem to be fairly well soldered in. They're not liable to dry joint anytime soon. That's one of the things that plagued a lot of cheap stuff, is really bad solder work, but the solder work in this looks pretty reasonable, if not overdone, which is a good thing. So yeah, we'll see how well it goes and how long it lasts. Good stuff.